All right, so in this video, we're going to talk about parabolas, the ones that don't necessarily open up or down anymore, but ones that open to the left or the right. So I'll refer to these as horizontal parabolas. So the equation would be x equals a y minus k squared plus h. The vertex is still the h and the k, but notice the h and the k can be found at different places now in this equation. A still equals 1 over 4p. But now, if a is positive, the parabola opens to the right. And if a is negative, it opens to the left. So again, now we have to look at things kind of from a different perspective. But let's take a look at an example. All right, so we'll start this one in a similar way where we'll need to complete the square to get it in standard form. Once again, I'm kind of a big fan of putting these blanks in here. We know that we want to complete the square with respect to a variable, so the y. Half of 1 is 1/2, and we need to square it. I put a 1/4 now on the right, so to keep it balanced, I'll need to put a negative 1/4 on the right as well. So again, we added 0. Now we have it factor into y plus 1/2 squared, and then this will be a negative 9/4 as a constant off to the side. So the vertex we can see would be the negative 9/4, negative 1/2. So make sure you get the coordinates from the correct spot. It's a little bit backwards from the way we did it in the last one. We'd also be interested in finding the focus and the directrix. But before we do that, we would need to find the p. And so let me go ahead and just sketch on here real quick what it is we're looking at. So negative 9/4, 1, 2, 3, negative 1/2. So our vertex, negative 9/4 is just a little more than 2, so 2 1/4. And then we come down 1/2. So we're about right here, if I can make this look decent. Okay. So to find the p, we know that a equals 1 over 4p. For us, a is equal to 1. So p would equal 1/4. So our a value being positive, we know this opens to the right. So a distance of 1/4 to the right puts us at our focus, and a distance of 1/4 units to the left puts us at our directrix. So if you can see here, I'll write it out so it's a little easier because we're dealing with some small numbers here. We're at negative 9/4. If we add 1/4, if we add the distance of p, that's going to give us negative 8/4, which is going to be negative 2. So our focus here would be at negative 2, negative 1/2. Now, if I take negative 9/4 minus 1/4, that moves us in the left-hand direction. That's going to be negative 10/4 or negative 5/2, and that's going to be where the directrix is. So x would equal negative 5/2. Okay, so let me go ahead and erase here. Now we need to find the intercepts. So to find an x-intercept, this is where we let y equal 0. And in this case, when we let y equal 0, you can see that x would equal negative 2, which again kind of makes sense in our picture. The y-intercept is where we let x equal 0. And this one actually, if you go back to the original, if we let x equal 0, this one actually factors into y plus 2 and y minus 1. So you can see a y equals negative 2 and a y equals 1 would be our intercepts here. So 0, negative 2, 0, negative 1. Positive 1 there. So negative 2 and positive 1. So here's our negative 2 and here's our positive 1. And if I connect the dots, I get a pretty decent picture of our parabola there. The axis of symmetry in this case would be a horizontal axis because of the direction the parabola opens. So the axis of symmetry in this case would be y equals -1/2. Remember, you can fold it directly over that axis of symmetry and it lies right on top of itself on the other side.